Hello, and welcome to Boring Science to Sleep, a quiet place where science becomes slow, soft, and easy to drift through. Tonight, we're going to gently explore our closest cosmic neighborhood, not to learn everything, but simply to notice it, one quiet step at a time. Together, we'll wander beyond the familiar planets, across silent fields of ancient ice, meet travelers that have crossed the darkness between stars, visit worlds unlike anything our imagination could easily invent, and eventually arrive among the galaxies that quietly surround our own. But before you settle in, if you truly enjoy these calm journeys through the quieter side of science, you're welcome to like this video and subscribe, only if it feels right for you. And when you're ready, let me know in the comments where you're listening from, and what time it is where you are. It's always a quiet joy to imagine so many peaceful moments unfolding together beneath the same universe. Now, dim the lights, perhaps let a fan hum softly in the background, allow your shoulders to loosen, and let your breathing become just a little slower. There is nowhere you need to go, nothing you need to remember, and nothing you need to solve tonight. You are safe. You are warm. You can simply listen, drift, and allow the universe to unfold around you as slowly as the stars themselves. Our journey begins close to home, at the quiet frontier where the familiar solar system slowly fades into darkness. For most of human history, the solar system seemed wonderfully complete. There was the bright sun, the familiar planets, and, beyond them, a darkness that appeared almost empty. People imagined that if they could somehow stand at the edge of Neptune's orbit and look outward, there might simply be nothing, a vast, silent ocean of space stretching endlessly into the cold. But the universe has always been kinder to curiosity than it first appears. It rarely reveals everything at once. Instead, it prefers to uncover its secrets slowly, almost as though it is inviting us to become more patient with every generation. If you imagine yourself drifting gently away from the sun tonight, you would notice something changing almost immediately. The warm golden light becomes softer, the planets spread farther apart, the spaces between them grow larger and quieter. Every familiar landmark begins to fade into the distance, until eventually even Neptune, the outermost giant, becomes only another pale point of light behind you. For a long time, astronomers believed this was nearly the end of the story. Then, almost by accident, the story quietly continued. In the year 1930, an astronomer named Clyde Tombaugh discovered a tiny world moving slowly against the background of distant stars. That world became known as Pluto. For decades, Pluto seemed wonderfully lonely. It was the first known object beyond Neptune, almost like a solitary lighthouse standing at the edge of a dark and frozen sea. People imagined it as the final member of the solar system's family, the last world before endless interstellar space began. Looking back now, that picture feels strangely peaceful, even if it was incomplete. Sometimes the universe allows us to believe a simple story for a while, only because the next chapter requires better eyes. The telescopes of the 20th century were remarkable for their time, but they still faced a difficult challenge. The farther an object travels from the sun, the less sunlight reaches it. And the less sunlight reaches it, the fainter it becomes. Imagine placing a tiny grain of ice many billions of kilometers away and asking someone on Earth to notice the faint sparkle reflected from its surface. That is very close to what astronomers were trying to do. The difficulty was not that these distant worlds were hiding, they were simply quiet. Their light was soft, their movements were slow, their presence demanded extraordinary patience. Nearly half a century passed before another important discovery quietly changed our picture of the outer solar system. Astronomers found Charon, Pluto's largest companion, gently circling its frozen partner through the darkness. Suddenly, Pluto no longer seemed completely alone. Even so, the greater mystery remained. Was Pluto unique? Or were there many more hidden worlds waiting beyond it? The answer arrived gradually, almost whispering instead of shouting. During the 1990s, improvements in digital cameras, computers, and careful sky surveys allowed astronomers to search areas of space that had once appeared almost impossible to study. Instead of examining individual stars one by one, they could patiently compare enormous images of the sky, searching for tiny points of light that moved ever so slightly from night to night. Most stars remained perfectly still, but every now and then, one tiny dot would quietly shift. That tiny movement often meant an entirely new world had been found. One of the earliest discoveries from this new era was a small icy object called Albion. It did not make dramatic headlines around the world, yet, in many ways, it quietly changed astronomy forever. Albion told scientists that Pluto had never been standing alone. It had simply been the first member of an enormous hidden neighborhood. It was rather like discovering one lonely cottage in a snowy forest, only to realize, years later, that an entire village had been hidden beyond the trees all along. From that moment forward, discoveries became more frequent. One frozen world after another slowly emerged from the darkness. Some were larger, some were smaller. Some traveled along nearly circular paths, while others wandered on remarkably stretched journeys that carried them astonishingly far from the sun. Each new discovery gently expanded the map of our own cosmic home. Among the astronomers helping redraw that map was Michael Brown, together with David Rabinowitz and Chad Trujillo. Their careful observations would eventually reveal several remarkable distant worlds, each one challenging old ideas about where the solar system truly ends. Yet even they were not searching for adventure. They were searching for patterns. Night after night, image after image, they patiently looked for the faintest motions against a background filled with millions upon millions of distant stars. Their work reminds us that science often moves much more like gardening than treasure hunting. You plant questions, you wait, you return again. You notice tiny changes that most people would never see, and eventually, something quietly grows. As more distant worlds appeared, astronomers realized they needed a new way to think about the outer solar system. Instead of imagining a sharp border beyond Neptune, they began to picture a vast frontier filled with countless frozen bodies, drifting peacefully through the darkness, like scattered islands floating across an endless polar sea. Some of these worlds were no larger than mountains. Others were almost large enough to become planets in their own right. Many had probably remained almost unchanged since the solar system itself was young, preserving ancient clues from a time when the sun had only just begun to shine. Without making a sound, these distant travelers had been patiently waiting for billions of years. All they required was enough time for curious eyes to notice them, and among those quiet, icy worlds, one in particular would soon capture the attention of astronomers around the world. Its surface reflected soft sunlight with surprising brightness. Its frozen landscape carried subtle shades of red, and its quiet journey around the sun would take longer than many human civilizations have existed. Its name was Makemake. Not every distant world announces itself with something dramatic. Some simply wait. Long after Pluto had shown astronomers that another frontier existed beyond Neptune, the search continued with extraordinary patience. Night after night, telescopes quietly gathered faint points of light, each image looking almost identical to the one before it. Most of those tiny specks never moved at all. They were distant stars, unimaginably far beyond our own solar system. But every so often, one tiny point would drift ever so slightly, not enough for anyone to notice with a casual glance. Only enough for careful eyes, returning again and again, to realize that something hidden had been quietly traveling through the darkness all along. That was how Makemake finally introduced itself. Its discovery did not arrive with an explosion of excitement. Instead, It felt more like finding an old photograph tucked inside a forgotten book. Once astronomers knew where to look, they searched older images taken years before and realized that Makemake had been there the whole time, silently crossing the sky while no one recognized what they were seeing. It had never been hiding. It had simply been waiting for us to notice. There is something strangely comforting about that thought. The universe is not always filled with sudden surprises. Sometimes it rewards patience instead. If you could gently drift outward from the Sun and continue past Neptune, you would eventually enter a vast region filled with frozen remnants from the earliest days of the solar system. This place is known as the Kuiper Belt, though it is easier to imagine it as an enormous ring of quiet, icy islands, each one moving peacefully along its own slow path. These worlds are separated by immense distances. Despite illustrations that often show them crowded together, they are, in reality, astonishingly lonely. If you stood upon one of these frozen bodies, another might be millions upon millions of kilometers away, invisible against the darkness. Makemake is one member of this quiet family. It belongs to a group of worlds whose paths remain relatively calm, far enough from Neptune that the giant planet rarely disturbs their journeys. Rather than dancing in close rhythm with Neptune's gravity, Makemake simply follows its own patient course, taking a little more than 3 centuries to complete a single orbit around the Sun. Imagine beginning a journey today. Before Makemake finishes just 1 year, entire nations would rise and disappear. Languages would change. Cities would grow into forests and forests into cities once again. Generations upon generations of people would live complete lives beneath Earth's skies, while Makemake continued tracing the same gentle path it has followed for billions of years. Time moves differently there. The sunlight does too. By the time sunlight reaches Makemake, it has become remarkably gentle. It no longer shines with the brilliant warmth we know on Earth. Instead, it spreads across the frozen landscape as a pale glow, just bright enough to paint long shadows across endless fields of ancient ice. Yet even this faint sunlight slowly transforms the surface. Makemake is covered largely by frozen methane, together with smaller amounts of ethane and nitrogen. These frozen gases form a landscape unlike anything found on Earth. Rather than soft snowflakes drifting through the air, the surface is coated with extremely cold crystals that have remained frozen for ages beyond imagination. Over countless millions of years, invisible ultraviolet light from the distant sun quietly changes some of these icy materials. Little by little, simple frozen molecules become more complex substances, creating reddish organic compounds that scientists call tholins. The name sounds technical. The process itself is beautifully simple. It is rather like watching fresh snow slowly change color beneath countless gentle sunsets, except that instead of days or seasons, the painting takes millions of years. That is why Makemake carries its subtle reddish color, not because the world is warm, not because it is active, but because sunlight has been patiently touching its frozen surface for an unimaginably long time. The temperatures here are almost impossible to compare with anything we experience on Earth. Everything remains deeply frozen. Nothing flows, nothing melts. Even the brightest moments of Makemake's long year never bring enough warmth to awaken the icy ground beneath its silent plains. If you were somehow standing there, your surroundings would appear almost perfectly still. No rivers would ripple across the landscape. No rain would fall from the sky. No breeze would carry drifting snow. Only silence. Only ancient ice stretching toward a black sky filled with brilliant stars. Although Makemake possesses an extremely thin veil of gas close to its surface, calling it an atmosphere almost feels too generous. It is so delicate that it would be difficult to imagine breathing through it, or even noticing it at all. Most of the time, this distant world simply rests beneath the open universe, exposed directly to space itself. For many years, Astronomers believed Makemake traveled completely alone. Then, while carefully studying images taken by the Hubble Space Telescope, they noticed something unexpected: a tiny companion, a small moon quietly circling its much larger partner. Today, this little satellite is commonly known by the simple nickname MK2. Compared with Makemake, it is remarkably dark, reflecting only a small amount of the sunlight that reaches it, while Makemake shines like bright frost beneath a winter sunrise. Its little companion resembles a quiet charcoal stone drifting faithfully nearby. Even now, scientists continue observing this distant pair. There are still questions waiting patiently for answers. Could Makemake possess another unseen moon? How did its icy surface form? What lies beneath those ancient frozen layers? No spacecraft has visited this world. The journey would take many years, even using the clever gravity of Jupiter to help push a spacecraft farther outward. For now, Makemake remains one of the solar system's quietest frontiers, revealing itself only through faint light collected by powerful telescopes here on Earth. And perhaps there is something fitting about that. Some places do not ask us to hurry toward them. Some places invite us simply to watch, to wonder, to return again and again, learning a little more each time. Far beyond Makemake, however, another world follows a far stranger path. Its journey carries it so incredibly far from the sun that even this quiet red world begins to seem almost close by comparison. Its name is Sedna, and its long voyage will carry us toward one of the most mysterious frontiers our solar system has ever revealed. There comes a moment, as you continue drifting farther from the sun, when even Makemake begins to feel surprisingly close. Its quiet red plains slowly fade behind you, until they become little more than another tiny memory suspended in the darkness. Ahead, the distances grow almost impossible to imagine. The silence seems deeper. Even sunlight, which has faithfully accompanied every step of your journey so far, begins to lose much of its familiar warmth. Somewhere in this immense frontier travels another distant world. Its name is Sedna. If Makemake feels like one of the quiet neighbors living at the edge of a peaceful village, Sedna is more like a solitary cabin standing far beyond the last visible light, where only the longest journeys ever arrive. Astronomers first noticed Sedna during the early years of the 21st century. At first glance, it appeared to be another distant frozen object, quietly moving across the background of countless stars. But as more observations accumulated, something remarkable began to emerge. Its path around the sun was unlike almost anything scientists had seen before. Most of the familiar planets travel along paths that, although enormous by human standards, still keep them comfortably within the sun's close family. Even the icy worlds beyond Neptune remain part of a recognizable neighborhood, returning again and again through regions that astronomers have gradually come to understand. Sedna is different. Its journey is astonishingly long. One complete orbit around the Sun takes roughly 11,500 Earth years. Imagine standing beside Sedna as it quietly begins one new year. Before that single year ends, nearly every chapter of recorded human history would have unfolded. Ancient civilizations would rise beside rivers, build cities, write stories, discover mathematics, look toward the heavens, and disappear into history long before Sedna returned to the same place again. For Sedna, our entire civilization occupies only a small moment along one peaceful journey. It is a beautiful reminder that nature measures time with many different clocks. When Sedna slowly approaches the sun, it never comes particularly close. Even at the nearest point of its long path, the sun would not appear as the brilliant glowing disk we know from Earth. Instead, it would resemble an extraordinarily bright star, shining steadily against a perfectly black sky. Enough light to cast gentle shadows, not enough to create warmth. As Sedna continues outward once more, the sunlight grows even softer, fading almost into memory. Eventually, it wanders into regions where the sun becomes little more than one bright star among countless others scattered across the heavens. It is because of this extraordinary journey that Sedna has become something of a puzzle. Astronomers often describe the outer solar system as having several quiet neighborhoods. The first is the Kuiper Belt, where Makemake peacefully travels. Farther beyond lies a much less orderly region known as the scattered disk. Rather than imagining it as a tidy ring, it may be easier to picture a wide shoreline after a powerful storm has passed. Pieces of ice have been carried outward in every direction. Some remain relatively nearby, others drift astonishingly far away, following slow and stretched paths that seem almost random. Many scientists believe Neptune played an important role in shaping this distant region long ago. As the giant planet slowly settled into its present orbit during the solar system's youth, its gravity gently nudged countless icy worlds outward. Some found stable homes. Others continued wandering much farther than anyone might have expected. It was less like throwing stones across a lake, and more like slowly pushing leaves onto different currents of an endless river. Sedna, however, does not fit perfectly even here. Its journey carries it so incredibly far from the Sun that some astronomers believe it may belong to another, even larger frontier. This distant region is called the Oort cloud. Unlike the Kuiper Belt, which forms something resembling a broad ring, the Oort cloud is often imagined as an enormous spherical shell surrounding the entire solar system. If the planets are tiny lanterns gathered around a campfire, then the Oort cloud is like the quiet forest stretching far beyond the circle of light. Most of its residents remain unseen. They are thought to be ancient icy bodies left behind from the birth of the solar system itself, drifting so far away that some may take millions of years to complete a single journey around the Sun. No one has ever photographed the Oort cloud directly. Its existence is instead suggested by the behavior of long-period comets that occasionally appear from astonishing distances before quietly returning to the darkness once again. Sedna seems to travel between these two great frontiers. It is too distant to feel comfortably at home among the Kuiper Belt, yet it never wanders quite deeply enough to fully join the imagined realm of the Oort cloud. It is a traveller living between neighbourhoods, neither entirely here, nor entirely there, and perhaps that uncertain place makes it even more fascinating. Despite the unimaginable cold surrounding Sedna, some researchers have wondered whether warmth might still exist deep beneath its frozen crust. Not warmth from the distant sun. That gentle light is far too weak. Instead, they imagine tiny amounts of heat slowly released inside the dwarf planet itself, generated by naturally occurring radioactive elements hidden within its rocky interior. Over immense stretches of time, that quiet source of energy could, in theory, preserve a small underground ocean beneath layers of ancient ice. No one knows whether such an ocean truly exists. For now, it remains a gentle possibility. One more quiet question, waiting patiently for future explorers. Sedna has also inspired another mystery. When astronomers carefully compared the paths of several distant icy worlds, they noticed something curious. A few of them seemed to share similar orbital patterns, almost as though something unseen were quietly guiding them from far away. One possible explanation is an undiscovered giant planet, sometimes called Planet 9. No telescope has confirmed its existence. No spacecraft has visited it. For now, it remains an elegant idea rather than a proven discovery, reminding us that even today, our own solar system may still contain places we have yet to find. Still farther away, another tiny object quietly circles the Sun. Astronomers affectionately named it Far-Far-Out. The name almost sounds playful, yet it describes something very real, one of the most distant objects ever observed while still remaining bound to our solar system. Even far out, however, is only another small marker along a journey that extends far beyond anything we can easily imagine. The farther we travel from the Sun, the less the solar system resembles a neatly organized collection of planets. Instead, it becomes something gentler, a gradual fading, a quiet transition from familiar worlds into the vast openness between stars. And somewhere within that openness, countless frozen travelers continue their endless journeys, carrying silent memories from the earliest days of our cosmic home. Some of them will never return, some will eventually wander close enough for us to notice, and a few may not belong to our solar system at all. They arrive from somewhere else entirely, crossing the darkness between stars before quietly continuing on their endless voyage. There is a comforting idea that every world always belongs exactly where we find it. The Earth circles the Sun, the Moon circles the Earth. The planets quietly follow their familiar paths, year after year, century after century, almost like careful dancers who never miss a single step. From where we live, the solar system appears wonderfully orderly. But if you could travel backward through time, returning to its earliest days, you would discover a very different place. It would not look peaceful. It would not yet have settled into the calm rhythm we know today. Instead, you would find an enormous cloud of gas and dust, slowly circling a very young sun. Tiny grains gently collided with one another. Some stuck together, others drifted apart again. Little by little, those grains became pebbles, the pebbles became rocky bodies, and eventually some grew large enough for gravity to begin gathering more and more material around them. Nothing happened all at once. The solar system was patient, even then. Millions upon millions of years passed as each world slowly found its place. Among the first giants to emerge were Jupiter, Saturn, Uranus, and Neptune. These enormous planets possessed gravity powerful enough to influence everything around them. Yet, gravity is not always like a hand reaching out to grab something. Sometimes it is more like the quiet current beneath the surface of a slow-moving river. You cannot see the current directly, but over time, it gently changes the paths of every leaf floating upon the water. Neptune became one of those quiet currents. Long ago, astronomers believed that Neptune slowly shifted outward from the Sun, moving only a modest distance compared with the immense scale of the solar system. It was not a sudden leap. It was an almost unimaginably slow migration, taking place over millions of years. As Neptune settled into its present home, countless icy bodies happened to cross its invisible field of influence. Some continued almost unchanged. Some found stable paths nearby. Others experienced gentle nudges, again and again, over extraordinary stretches of time. Each tiny adjustment seemed insignificant on its own. Yet together, they completely reshaped the outer solar system. Imagine standing beside a peaceful lake during autumn. Leaves float quietly upon the surface. A light breeze arrives. No single leaf moves very far in a single moment. But after hours have passed, some leaves have gathered near the shore, others have drifted toward the center, while a few have quietly disappeared beyond the reeds where you can no longer see them. Neptune's gravity behaved in much the same way, not by throwing worlds violently into darkness, but by patiently guiding them onto new journeys that sometimes lasted billions of years. Many of those travelers became members of the broad region astronomers now call the scattered disk. Their paths grew longer, their journeys became more stretched. Some would return toward the Sun after many centuries. Others wandered so far outward that they seemed almost ready to leave the solar system entirely. Beyond them lies the imagined frontier known as the Oort cloud. Unlike the flattened shape of the planetary system, the Oort cloud is thought to surround the Sun in every direction, almost like an enormous sphere of quiet ice, extending far beyond the most distant planets. If our solar system were a softly glowing lantern hanging in a vast forest at night, the Oort cloud would resemble the faint mist surrounding that lantern. fading gradually into complete darkness. No one has ever photographed this distant realm directly. It is simply too far away. Instead, astronomers have learned about it by watching occasional visitors arrive from those unimaginable distances. Every so often, a comet appears. It slowly brightens as it approaches the sun, grows a beautiful glowing tail, and then quietly disappears once more into the darkness from which it came. Its journey suggests that somewhere far beyond our sight, an immense population of ancient icy bodies continues drifting through the outermost frontier of the sun's influence. But the story does not end there. Sometimes the quiet currents become just a little stronger. A passing star may drift through our part of the galaxy, not close enough to threaten the planets, only close enough to slightly disturb the most distant icy objects resting near the edge of the sun's domain. The effect is remarkably gentle, like a distant breeze reaching the highest branches of an old forest. Most of the trees remain perfectly still. Only a few leaves begin drifting downward. Those tiny disturbances may slowly redirect some frozen bodies toward the inner solar system, where we occasionally see them as long-period comets. Others are nudged in the opposite direction. Their connection to the sun becomes weaker and weaker until, at last, they quietly slip away. No explosion marks the moment, no dramatic farewell. One gentle orbit simply becomes another, until the object is no longer truly bound to the sun at all. It begins an entirely different life, not as a resident of one planetary system, but as a traveler between stars. Interstellar space often sounds empty when we hear those words, the empty space between stars. Yet emptiness can be surprisingly full of quiet things. Tiny grains of dust drift through the galaxy. Invisible clouds of gas slowly gather over millions of years. Ancient molecules float in darkness, so cold that they scarcely move at all, and among them, here and there, lonely fragments of planetary systems continue their endless journeys. Some are pieces of rock, some are frozen worlds. Some may once have circled distant stars before gravity gently encouraged them to continue traveling alone. Imagine thousands of ships leaving different harbors over countless centuries. Eventually, they all enter the same great ocean. Looking at one ship, it becomes almost impossible to know where its voyage first began. The galaxy is rather like that. Every star slowly releases tiny pieces of its own history. Not intentionally, simply because gravity is forever shaping and reshaping the paths of everything that moves. Even our own solar system has probably contributed a few wandering travelers to this immense galactic sea. Perhaps somewhere, unimaginably far away, another civilization might one day notice one of our ancient icy worlds passing silently through their skies. They may wonder where it came from. They may never know. In the same quiet way, visitors from distant stars occasionally wander into our own neighborhood. They arrive without announcing themselves. They carry memories of places we have never seen. For a short time, they pass through the gentle light of our sun. Then they continue onward into the darkness once again, leaving behind only questions, observations, and a quiet sense of wonder. One such traveler appeared not long ago, looking surprisingly familiar despite having spent countless ages between the stars. Another would prove even more mysterious. Together, they would become the first known visitors from beyond our own solar system. Long before people understood what comets truly were, they often looked upon them with uncertainty. A bright tail appearing unexpectedly in the night sky could seem mysterious, even unsettling. Some believed comets carried warnings. Others imagined they were signs from distant heavens. Today, we understand them a little differently. A comet is less like a messenger bringing dramatic news, and more like an old traveler carrying quiet memories. Most comets spend nearly all of their existence in extraordinary silence. Far from the warmth of any nearby star, they drift through darkness so complete that almost nothing changes from one century to the next. Frozen gases remain locked inside them. Tiny grains of ancient dust wait patiently beneath layers of ice. Time itself seems to move more gently. Only when a comet slowly approaches a star does it begin to awaken. Sunlight warms its surface. Some of the frozen ice quietly changes into gas, escaping into space and carrying tiny dust particles along with it. Gradually, a soft glowing cloud forms around the comet, followed by the beautiful tale that has inspired human curiosity for thousands of years. Every comet tells a story. Most of those stories begin here, within our own solar system. But every now and then, one seems to whisper about somewhere much farther away. One intriguing example is a comet known as Machholz. Its full scientific name is much longer, but tonight there is no need to remember every letter and number. Like many travelers, it is easier simply to know it by its name. Machholz follows a remarkably unusual path around the Sun. Rather than traveling in nearly the same broad plane as most planets and many other comets, its journey is steeply tilted, almost as though it chose an entirely different road through the solar system. Its chemistry has also attracted attention. When astronomers studied the gases released from its icy surface, they found that some familiar molecules appeared in surprisingly small amounts, while others seemed more abundant than expected. Nothing about this proves that Machholz came from another star. Nature is wonderfully creative. Different parts of the same solar system can produce surprisingly different objects. Yet unusual details encourage scientists to ask gentle questions rather than rush toward confident answers. Could Machholz have formed under conditions unlike those experienced by most known comets? Has its long history near the Sun slowly changed its chemistry? Or might it have experienced an origin more complicated than we currently understand? Science is comfortable with quiet uncertainty. Sometimes the most honest answer is simply that we are still learning. Machholz reminds us that curiosity often begins with noticing small differences. Not every mystery requires an immediate solution. Sometimes it simply asks us to keep watching. A few years later, astronomers would discover another traveler. This one, however, carried almost no uncertainty about where it came from. Its name was Borisov. Unlike Machholz, Borisov was immediately recognized as something extraordinary. When astronomers carefully calculated its path, they found that it was not moving around the Sun in the gentle, looping journey expected of ordinary comets. Instead, it was following a path that carried it through the solar system only once. Imagine a quiet bird flying through a forest. Most birds belong there. They build nests. They return each season. They know every familiar tree. Now imagine another bird arriving from a forest hundreds of kilometers away. It pauses briefly among unfamiliar branches before continuing toward another distant horizon. That second bird is rather like Borisov. It was never truly part of our solar system. It was simply passing through. Long before it reached our Sun, Borisov had almost certainly spent millions, perhaps even billions of years, traveling through the dark spaces between stars. No one knows exactly which star it once called home. That information has been gently erased by time. Over immense distances, every star continues moving around the center of our galaxy. Planetary systems slowly drift apart. Ancient paths become impossible to trace backward with complete certainty. The road disappears. Only the traveler remains. As Borisov approached the Sun, astronomers watched with tremendous care. Would an interstellar comet look completely different from our own? Would its chemistry reveal an unfamiliar kind of planetary system? The answer turned out to be both surprising and strangely comforting. In many ways, Borisov behaved just like an ordinary comet born here at home. Its icy surface released familiar gases. Its glowing cloud expanded naturally. Its delicate tail stretched gracefully away from the Sun. Rather than appearing completely alien, Borisov suggested something beautiful. Perhaps planetary systems across our galaxy are not entirely different from our own. Perhaps the same quiet laws of physics that shaped Earth, Jupiter, and distant Makemake have also been patiently building icy worlds around countless other stars. It is a comforting thought. The universe may be unimaginably large, yet it often creates beauty using the same gentle patterns. Snowflakes fall differently, yet every snowflake grows from the same quiet process. Forests contain countless trees, each unique, yet all nourished by sunlight and water. Perhaps stars build their planetary families in much the same way, not identically, but with familiar rhythms repeated across the galaxy. During its brief visit, Borisov offered scientists a precious opportunity. Without traveling to another star, humanity was able to study material that had formed around one. Tiny grains of dust, frozen gases, ancient chemical fingerprints preserved since long before human civilization began. For a short while, another solar system quietly introduced itself. Then, just as gently as it had arrived, Borisov continued its endless journey. The sun's gravity bent its path slightly, offering only a brief greeting before releasing the traveler back into the great darkness between stars. It will never return. Millions of years from now, Borisov may pass another distant sun. Perhaps another planetary family will briefly illuminate its icy surface before it disappears once again into the quiet sea of interstellar space. There is something strangely peaceful about that endless voyage. No destination, no urgency, only motion, only time, only the slow conversation between gravity and distance. Yet even Borisov was not the first interstellar visitor humanity ever noticed. A little earlier, another object had crossed our skies. Unlike Borisov, it refused to fit comfortably into familiar categories. Its shape was unexpected. Its behavior inspired years of careful debate. And even today, it continues to remind us that the universe still holds quiet surprises for anyone patient enough to look toward the stars. Not every traveler announces where it has come from. Some simply appear. For a brief moment, they share the same sky as you, and then, before you have fully understood who they are, they quietly disappear again into the darkness. That was the story of an object now known as Oumuamua. Its name comes from the Hawaiian language and is often translated as a messenger arriving from afar or a scout sent ahead to explore. It is a beautiful name, one that feels gentle enough for something that spent countless ages drifting between the stars before briefly passing through our own little corner of the galaxy. No one saw it approaching. By the time astronomers discovered it, Oumuamua had already passed its closest approach to the sun. It was already leaving. Imagine walking through a quiet forest after a light snowfall. You notice a single line of footprints crossing the path. Whoever made them has already disappeared beyond the trees. The footprints remain, the traveler does not. That was the challenge facing astronomers. There would be no opportunity to wait for another orbit, no chance to prepare a spacecraft years in advance. Oumuamua was visiting only once. Every observation suddenly became precious. Powerful telescopes around the world turned toward the small object, gathering every faint glimmer of reflected sunlight they could, before it became too distant to see. Even then, Oumuamua remained only a tiny point of light. No telescope could photograph mountains or valleys upon its surface. No camera could reveal its true appearance directly. Instead, scientists watched the subtle changes in its brightness as it slowly rotated through space. Those changes suggested something unexpected. Unlike the nearly rounded shapes of many asteroids, Oumuamua appeared to be remarkably elongated. Perhaps it resembled a long cigar. Perhaps it looked more like a broad, flat pancake. The truth is that no one knows with complete certainty. The available observations were simply too limited. It is rather like trying to understand the shape of a leaf by watching only its shadow drifting across the ground. You may learn something. You will never learn everything. That uncertainty is part of the story, and perhaps part of its quiet beauty. As astronomers continued studying its journey, they noticed another curious detail. The sun's gravity alone did not seem to explain every tiny part of its motion. There appeared to be a very small additional push as Oumuamua continued moving away. Not a dramatic acceleration, not a sudden burst of speed, only the gentlest extra motion. For many comets, such behavior is perfectly ordinary. As sunlight warms frozen ice, escaping gas acts almost like an invisible breath, giving the comet a tiny natural push. Yet Oumuamua showed no obvious glowing cloud, no bright tail, no easily visible signs of escaping gas. This small mystery inspired many careful ideas. Some researchers suggested that perhaps the escaping gas was made of materials difficult for our telescopes to detect. Others imagined that sunlight itself might have gently pushed an unusually thin object, almost the way a breeze can slowly carry a feather across still water. Another possibility proposed that Oumuamua might once have been part of a larger icy world that ventured too close to its own star. The tremendous gravity could have stretched and fractured that ancient body, leaving behind long, irregular fragments that later wandered into interstellar space. Each explanation attempts to fit the observations as naturally as possible. None has yet answered every question completely, and that is perfectly acceptable. Science is not uncomfortable with uncertainty. It simply continues listening. For a short time after its discovery, another idea attracted considerable public attention. Some people wondered whether Oumuamua might be an artificial object, perhaps even a distant spacecraft. The suggestion captured imaginations around the world because it sounded extraordinary. But imagination and evidence are not the same thing. Astronomers examined every observation available. Again and again, they searched for signs that would support such an unusual conclusion. None appeared. No radio signals, no controlled movements, no unmistakable indications of technology. Instead, every new study continued, pointing toward natural explanations, even if those explanations remain incomplete in certain details. One of the quiet strengths of science is its patience. When the evidence is incomplete, it resists the temptation to invent certainty. It simply says, "We do not yet know." There is something deeply peaceful about those 4 words. They leave room for tomorrow. Oumuamua eventually became too faint for even our largest telescopes. Its tiny reflection faded into darkness until it could no longer be followed. It continues traveling today, far beyond the planets, far beyond the icy frontier where Sedna slowly circles the sun, far beyond the distant cloud of ancient comets. One day, millions of years from now, it may pass another star. Perhaps another planetary system will briefly illuminate its surface before releasing it once again into the great darkness between worlds. It is impossible to know, yet its brief visit changed astronomy forever. Before Oumuamua, interstellar objects belonged mostly to theory. After its discovery, they became something wonderfully real. Scientists realized that visitors from other stars may be more common than anyone had imagined. We had simply not been looking carefully enough. Naturally, this inspired another question. What if the next visitor could be explored more closely? Several research teams began imagining future missions designed to respond rapidly whenever another interstellar traveler appeared. Instead of spending years preparing after a discovery, spacecraft could already be waiting, ready to begin their journey almost immediately. One particularly ambitious idea is known as Breakthrough Starshot. Its long-term dream reaches far beyond Oumuamua itself. Researchers hope that one day, incredibly light spacecraft, pushed by powerful beams of light, might travel faster than anything humanity has ever built before. Not to conquer distant stars, not to disturb them, simply to see them, to quietly gather a few images, to learn, to understand. Even if such journeys remain far in the future, They remind us of something important. Curiosity itself travels. Long before spacecraft arrive, questions begin their own journeys. They cross generations. They pass from teacher to student, from one astronomer to another, from one quiet night beneath the stars to the next. Oumuamua is already far beyond our reach. We will almost certainly never see it again. Yet its passing has gently changed the way we look toward the darkness between stars. What once seemed like an empty ocean now feels more like a great sea crossed by countless unseen travelers, each carrying a story written around a different sun. And somewhere among those countless journeys, entire families of planets quietly circle distant stars. Some are peaceful, some are astonishingly strange, some are so unlike our own world that they almost seem impossible. As our own voyage continues, those remarkable worlds will slowly come into view, reminding us that nature often imagines landscapes far beyond anything we would have dared to invent ourselves. As the last traces of our interstellar visitors slowly disappear into the darkness, you may find yourself wondering about the stars they once passed. Somewhere, long ago, Borisov almost certainly circled another sun. Oumuamua may also have begun its journey around a star we will never be able to identify with certainty. Those distant homes remain unknown, yet they invite a gentle question. If every star has its own family of planets, do those families all grow in the same way? The simple answer is no, and perhaps that should not surprise us. Even here on Earth, no two forests grow into exactly the same shape. Two rivers flowing across neighboring valleys will slowly carve different paths through the landscape. Children raised in different homes may share many similarities, yet each family develops its own quiet traditions over time. Planetary systems seem to behave in much the same way. The laws of physics remain beautifully consistent throughout the universe. Gravity behaves the same. Light behaves the same. Matter follows the same quiet rules. Yet the countless small differences present at the beginning of each new solar system gradually create worlds that are wonderfully unique. If you could watch the birth of a young star, you would not see planets waiting nearby. Instead, you would first notice an enormous cloud of gas and fine dust, slowly turning around the newborn star, like gentle mist circling a calm lake. Within that broad disk, tiny particles begin meeting one another. Some drift apart again, others quietly remain together. Over immense stretches of time, those tiny grains become pebbles. The pebbles slowly become rocks. The rocks become mountain-sized bodies. Eventually, gravity becomes strong enough to gather even more material, patiently building the first young planets. It is less like constructing a building. It is more like watching snow gather upon a quiet hillside. One snowflake settles, then another, and another. None of them seem important on their own, yet together they slowly transform the entire landscape. For a long time, astronomers imagined that once planets formed, they simply stayed where they were born. It was an understandable idea. After all, our own solar system appears wonderfully organized. Small rocky planets remain close to the sun. Large gas giants live much farther away. Everything seems comfortably arranged. But as astronomers discovered more planetary systems around distant stars, they realized nature was telling a far more interesting story. Some enormous planets circled astonishingly close to their stars. Others followed unusually stretched paths. Some worlds traveled around two stars instead of one. Others appeared packed tightly together, moving in elegant rhythms that looked almost like a carefully choreographed dance. How could such different systems exist? The answer, once again, lies in patience. Planets are not always born exactly where we find them today. Some begin their lives far from their stars before slowly drifting inward over millions of years. Others move outward. Some gently exchange energy with neighboring planets, gradually changing one another's paths without ever touching. Imagine several small boats floating upon a calm lake. No boat intends to move another, yet every passing wave gently changes their positions. Given enough time, the entire group slowly rearranges itself. Gravity works in a remarkably similar way. It rarely rushes. It rarely forces sudden change. Instead, it whispers, again and again, until millions of tiny influences become one extraordinary result. This slow wandering is often called planetary migration. The name sounds technical. The idea itself is wonderfully simple. Planets can slowly change neighborhoods. Some drift closer to the warmth of their stars. Others wander farther away. The journey may take millions of years. No living creature would ever notice it happening in real time. Yet when we observe mature planetary systems across our galaxy, we are seeing the quiet results of those ancient journeys. Sometimes two giant planets pass close enough to gently alter one another's paths. Sometimes a disk of gas slowly pulls a young planet inward. Sometimes smaller worlds are quietly scattered into distant regions. And occasionally, as we explored earlier tonight, one may even be released entirely, beginning an endless voyage between the stars. Every planetary family carries its own history. Just as every old tree contains rings that quietly record changing seasons, every planetary system preserves the memory of countless slow events that shaped it long ago. Astronomers have now discovered thousands of planets beyond our solar system. At first, many people expected these discoveries to make the universe feel more familiar. Instead, they revealed something even more beautiful. Nature possesses an extraordinary imagination. Some planets are larger than Jupiter yet circle astonishingly close to their stars. Others are covered by oceans of molten rock. Some may have skies filled with thick clouds unlike anything above Earth. Others complete an entire year in only a few days, while some wander so far from their stars that 1 year lasts longer than entire chapters of human civilization. Every discovery gently reminds us of the same quiet truth. Earth is not the standard by which the universe measures itself. Earth is simply one peaceful possibility among countless others. There is something deeply comforting about that idea. Our world is neither the center of everything nor an isolated miracle. Instead, it is one small expression of the same patient universe that continues creating planets wherever stars are born. The details change. The beauty remains. As telescopes improved, astronomers began discovering worlds that seemed almost impossible at first glance. One reflected almost no light at all, appearing darker than fresh charcoal beneath a moonless sky. Another seemed to glow with oceans of molten stone. Still others orbited so close to their stars that their landscapes were being slowly reshaped by unimaginable heat. Each discovery sounded more surprising than the last. Yet none of them required new laws of physics. Only the same familiar forces, given enough time, working under different conditions. Perhaps that is one of the quiet lessons the universe offers us again and again. Remarkable places do not always require remarkable rules. Sometimes ordinary laws, acting patiently for billions of years, are more than enough to create extraordinary worlds. And among all those distant planets, one in particular almost seemed to disappear into the darkness itself. It reflected so little starlight that, against the blackness of space, it became one of the darkest worlds humanity has ever found. Nearby, another glowed with such intense heat that its rocky surface may never truly know what it means to cool. By now, you may have begun to notice something gentle about the universe. The farther you travel, the less it tries to repeat itself. Each new place seems familiar enough to recognize, yet different enough to quietly surprise you. The same gravity that shaped our own Earth also shaped worlds of frozen methane far beyond Neptune. The same gravity released lonely travelers into the darkness between the stars. And now, as you drift toward distant planetary systems, it reveals another truth. Not every planet is meant to resemble home. Some worlds seem to gather light, others almost refuse to return it. Among the most remarkable is a distant giant known as TRES 2b. Its name may sound unusual, but there is no need to remember it. What matters is the quiet mystery it represents. Imagine standing beneath the clearest night sky you have ever seen. Above you, countless stars shine softly. Now imagine placing a perfectly smooth black stone against that sky. The stone would disappear almost completely. That is something like the appearance of this distant planet. Astronomers discovered that it reflects only a tiny amount of the light reaching its atmosphere. Compared with planets like Jupiter, whose clouds gently scatter sunlight back into space, TRES 2b seems to quietly absorb almost everything. It is often described as one of the darkest planets ever discovered. Not because it is invisible, not because it is made of some unknown substance, simply because its atmosphere is extraordinarily efficient at holding onto light instead of sending it back. If Earth were somehow transported into the same place, our skies would become almost unrecognizable. The planet circles remarkably close to its parent star. A complete year there lasts only a few Earth days. Its daylight never enjoys the gentle warmth of a spring afternoon. Instead, the world remains intensely heated almost without pause. At such temperatures, the atmosphere behaves in unfamiliar ways. Clouds that brighten other planets struggle to form. Instead of reflecting light, the gases absorb much of it, allowing darkness to dominate despite the fierce brightness of the nearby star. It is a strange combination, a place surrounded by brilliant light, yet wrapped in extraordinary darkness. Nature sometimes enjoys creating quiet opposites. The hottest places are not always the brightest. The brightest stars may illuminate worlds that remain surprisingly dark. As astronomers continued searching the galaxy, another remarkable planet slowly entered view. This one is known as 55 Cancri E. Unlike the enormous gas giants that resemble Jupiter, this distant world is believed to be mostly rocky. If you could somehow approach it safely, you would not find peaceful mountains or quiet oceans waiting below. Instead, much of its surface may glow with intense heat. Many scientists imagine vast regions covered by molten rock, slowly flowing like unimaginably slow rivers of liquid fire. Yet even the word fire is not quite right. Fire, as we know it on Earth, depends upon oxygen in our atmosphere. The glowing surface of this distant planet is something altogether different. The rocks themselves become so hot that they shine. Imagine a blacksmith heating iron inside a quiet workshop. As the metal grows hotter, it slowly changes from dark grey to deep red, then orange, and eventually becomes brilliantly bright. Now imagine an entire world glowing in that same patient way, not because flames cover its surface, simply because the stone itself has become extraordinarily hot. This remarkable planet circles so close to its star that one side may spend its entire existence facing the light. If that is true, then one hemisphere experiences endless day, while the opposite side remains in continuous night. The idea may sound unfamiliar at first, yet our own moon quietly offers a small reminder. One side always faces Earth, the other always faces away. In much the same way, some planets become locked into a steady rhythm with their stars, turning so slowly that the same face continues greeting the sunlight year after year. Imagine standing forever beneath the same sunrise, not watching it rise, not watching it set, simply living beneath its endless glow. Elsewhere on the planet, another traveler would experience an endless night that never quite reaches morning. Between those two extremes may exist regions where day and night quietly meet, although conditions there would still be far beyond anything humans could comfortably endure. Several years ago, one scientific idea captured public imagination. Researchers suggested that this remarkable world might contain enormous amounts of carbon deep inside its interior, compressed under extraordinary pressures. If so, some people wondered whether parts of the planet could contain diamond. New observations have since painted a more complicated picture. Today, astronomers are less certain that the planet truly deserves the nickname of the Diamond World. Its interior is probably far more complex than early studies suggested. Yet, that uncertainty does not diminish its beauty. In science, changing our understanding is not a mistake, it is progress. Each new observation gently replaces an older picture with one that is just a little clearer. Like cleaning frost from a window on a quiet winter morning, the landscape beyond gradually becomes easier to see. The more astronomers studied planets like these, the more they realized that worlds can exist under conditions far beyond everyday imagination. Some are darker than fresh charcoal, some glow with oceans of molten stone, others experience temperatures so different between one side and the other that they almost seem like two separate worlds joined together. Yet every one of them still follows the same patient laws that govern Earth. Gravity quietly shapes their paths, light gently warms their surfaces, time slowly changes them. The universe does not invent entirely new rules simply because a place appears unusual. It creates astonishing variety using the same quiet principles again and again. There is something deeply comforting about that thought. It reminds us that Earth is not ordinary because every planet resembles it. Earth is extraordinary because, among such immense diversity, it happens to provide a place where rivers can flow gently, clouds can drift peacefully overhead, forests can quietly grow, and living creatures can spend calm evenings looking upward toward the stars. Perhaps we appreciate home most clearly after wandering far enough to understand how many different homes nature is capable of creating. And still, even these extraordinary worlds are not the most surprising places astronomers have found. Far away, another small family of planets circles something very different from an ordinary star. Their parent is not quietly shining like our sun. Long ago, it experienced one of the most violent endings a star can know. Yet somehow, against every expectation, planets continued their patient journeys around what remained. The universe has a gentle way of changing our expectations. Just when you begin to think you understand where planets belong, it quietly shows you another possibility. We often imagine planets circling calm stars like our sun. Warm light, steady seasons, billions of peaceful years. It feels natural, comfortable, almost inevitable. But nature rarely limits itself to only one way of creating beauty. Sometimes a star reaches the end of one life and begins another. Sometimes that ending seems so dramatic that it appears impossible for anything nearby to survive. And yet, every now and then, something does. To understand these remarkable worlds, it helps to first imagine an enormous star living a long and brilliant life. For millions of years, it quietly transforms lighter elements into heavier ones deep within its glowing heart. Outwardly, it shines with extraordinary confidence, balancing its own immense gravity through the energy produced at its center. But nothing in the universe remains unchanged forever. Eventually, even the largest stars begin running out of the fuel that has supported them for so long. Their balance slowly weakens. Their final chapter approaches. For the most massive stars, that ending can become one of the most energetic events in the universe. The outer layers are thrown outward into space. The central region collapses with astonishing speed. What remains is an object so incredibly dense that a single spoonful of its material would outweigh mountains here on Earth. This remarkable remnant is known as a neutron star. The name sounds highly technical. It may be easier simply to imagine it as the quiet heart left behind after a giant star has finished shining. Some neutron stars rotate extraordinarily quickly. As they spin, powerful beams of energy sweep across space. If one of those beams repeatedly crosses Earth's line of sight, astronomers observe an incredibly steady series of pulses, rather like a lighthouse standing beside an endless cosmic sea. The lighthouse itself does not blink, it simply turns. Its beam quietly returns again, and again, and again. Because of this steady rhythm, these remarkable objects are called pulsars. Their signals are so regular that, when they were first discovered, a few scientists briefly wondered whether they might somehow be artificial. That idea quickly faded as more observations revealed their natural origin. The universe had simply created another beautiful rhythm. Then, during the early 1990s, astronomers studying one particular pulsar noticed something unusual. Its steady pulses were arriving just a tiny bit earlier or later than expected. Not by much, only enough to suggest that something invisible was gently tugging on the pulsar as it moved. The explanation slowly emerged. Small worlds were orbiting it. These became the first confirmed planets ever discovered beyond our own solar system. Long before thousands of exoplanets filled astronomical catalogues, these quiet companions had already been waiting beside a stellar remnant. One of them eventually became known by the memorable nickname Poltergeist. The name sounds playful, perhaps even mysterious, yet the planet itself behaves with complete indifference to human imagination. It simply continues its quiet journey around a star that no longer resembles the warm suns we usually associate with planetary systems. For many people, the discovery raised an obvious question. How could planets possibly exist around something born from such a violent event? The answer remains an active area of research, and several gentle possibilities have been explored. Perhaps these planets somehow survived the star's dramatic transformation. If they had been far enough away, they might have endured while everything around them changed. Another possibility is that the original planets were destroyed, leaving behind enormous clouds of debris. Over immense stretches of time, those scattered fragments could have slowly gathered together once again, quietly forming an entirely new generation of planets. Neither idea requires impossible physics, only patience. The universe often rebuilds itself using whatever materials remain. Imagine an old forest after a powerful storm. Several ancient trees have fallen. The landscape appears transformed, yet seasons continue passing. Seeds quietly settle into the open ground. Young trees begin growing beneath the sunlight now reaching the forest floor. Years become centuries. The forest returns, not identical, but alive once again. Planetary systems may sometimes behave in much the same way. Endings become beginnings. Destruction quietly prepares the conditions for renewal. Another remarkable example can be found around a distant star known as Kepler-70. Unlike a pulsar, this star followed a gentler path as it aged. After spending billions of years shining much like our own sun, it eventually expanded into a red giant before shedding much of its outer atmosphere. What remained was a compact stellar core, surrounded by the fading memory of its former self. Astronomers were astonished to discover tiny planets orbiting extraordinarily close to this evolved star. These worlds travel so near their parent that they experience incredible heat. Their years are astonishingly short. They complete one full journey around their star in less time than many people spend enjoying a long weekend. How they arrived there remains another quiet mystery. Perhaps they formed farther away before slowly drifting inward. Perhaps they survived remarkable changes as their star evolved around them. Or perhaps several different processes worked together over unimaginable spans of time. Again, science offers possibilities rather than certainty. That quiet honesty is one of its greatest strengths. When we look at systems like these, it becomes tempting to describe them as impossible. Yet the universe gently reminds us that impossible is often only another word for unfamiliar. These planets are not breaking the laws of nature. They are simply revealing possibilities we had never considered before. Every new discovery stretches our imagination a little farther, while leaving the underlying rules beautifully unchanged. Gravity continues its patient work. Time continues its silent work. Stars are born. Stars grow older. Stars transform. Planets respond. Some disappear. Some survive. Some begin entirely new stories after everything around them seems to have ended. Perhaps that is one of the quiet lessons hidden among these distant worlds. Survival does not always mean remaining unchanged. Sometimes survival means adapting so slowly that change becomes almost invisible until millions of years have passed. The universe has been practicing that quiet art for far longer than humanity has existed. And as our journey continues, we will soon meet another family of worlds where change has become even more visible. Planets so close to their stars that gravity itself is slowly pulling them apart, allowing their very atmospheres to drift away into space, one gentle breath at a time. By now, your journey has carried you across frozen worlds, lonely travelers between the stars, planets wrapped in darkness, and quiet survivors that endured the deaths of their own suns. You may have noticed something that gently connects every place we have visited. Nothing remains exactly the same. Even when change is far too slow for human eyes to witness, it is always there. Mountains slowly wear away. Stars quietly grow older. Galaxies drift through space. Planets, too, continue their own patient journeys. Some slowly cool. Some gradually wander into new orbits. And a few spend billions of years moving ever closer to the stars that first gave them life. One of the most remarkable examples is a distant world known as WASP-12b. Like many scientific names, it sounds more complicated than the object itself. Tonight, there is no need to remember every letter. Instead, simply imagine a giant planet living far closer to its star than Jupiter could ever safely exist around our own sun. If Jupiter were somehow placed where WASP-12b now circles, it would become almost unrecognizable. The calm bands of clouds we admire today would be transformed by overwhelming heat. Its atmosphere would stretch outward. Its familiar appearance would slowly disappear. Distance matters. A small change in the space between a planet and its star can quietly reshape an entire world. WASP-12b completes one full journey around its star in just a little more than a single Earth day. Its year is so brief that while you enjoy a peaceful night's sleep, this distant giant would already have completed a large portion of another orbit. Yet, despite moving so quickly, the planet is not escaping. Instead, it remains tightly bound to its star, held by gravity's steady embrace. Gravity is often imagined as something that simply pulls. In reality, it also stretches. You have already seen a gentle example much closer to home. Earth's oceans slowly rise and fall, because the moon pulls ever so slightly more strongly on one side of our planet than the other. The difference is tiny, yet it is enough to create the familiar rhythm of the tides. Now imagine replacing the gentle influence of the moon with the overwhelming pull of a nearby star. The stretching becomes far greater. Instead of lifting oceans by only a few meters, gravity begins gently pulling at the entire planet itself. Not suddenly, not violently, slowly, patiently, almost tenderly. Astronomers describe these effects as tidal forces. The words may sound technical. The image is wonderfully simple. Imagine holding a piece of soft bread with both hands. If you gently pull from opposite ends, the bread slowly changes shape. Nothing breaks immediately. It simply becomes longer and thinner. Gravity performs a similar quiet motion across enormous distances. Over immense spans of time, the planet responds. Its atmosphere becomes less tightly held. The outer layers begin drifting away into space. Not in great explosions, not in dramatic clouds racing outward. Rather, the atmosphere escapes almost like steam rising from a warm cup of tea on a quiet morning. A little today, a little tomorrow, a little again after another 1,000 years. Each moment seems insignificant. Together, they become transformation. Powerful space telescopes have detected evidence that WASP-12b is indeed losing material. Some of its outer gases appear to be flowing away under the combined influence of heat and gravity. The star is not intentionally consuming its companion. Nature has no intentions, only processes, only causes gently leading toward effects. Yet from our human perspective, it is difficult not to imagine the planet slowly dissolving into the brilliant light surrounding it. Its future seems quietly written. Given enough time, gravity will likely continue drawing it ever closer. Its atmosphere will continue thinning. Eventually, much of the giant world itself may disappear into the star that has shaped its existence since the very beginning. There is something strangely peaceful about this story, not because it ends, but because the ending arrives so slowly. Nothing hurries, nothing struggles. The universe allows change to unfold over millions of years, almost too gradually for any single moment to notice. Even destruction can become gentle when time itself is unimaginably patient. As astronomers discovered more planets like WASP-12b, they began recognizing an entire family of worlds now called hot Jupiters. These are giant planets, similar in size to Jupiter, yet living astonishingly close to their stars. At first, their existence seemed almost impossible. Most theories suggested that such enormous planets should form much farther away, where colder temperatures allow abundant gas to gather during their earliest years. So how did they arrive so close? Once again, the answer appears to involve slow movement rather than sudden creation. Many scientists believe these giant planets were probably born in colder regions, far from their stars. Over countless millions of years, gentle interactions with surrounding gas and neighboring planets slowly guided them inward. They did not rush, they wandered, almost like leaves carried downstream by an invisible current. By the time the surrounding cloud of gas disappeared, the planets had already settled into their new homes, homes that were far warmer than where they had first opened their long journeys. It is a quiet reminder that a planet's birthplace and its final home are not always the same. The universe is full of travelers. Some cross the darkness between stars, some migrate within their own families, some drift so close to their suns that they slowly surrender pieces of themselves with every passing age. Perhaps that sounds a little sad, yet it is simply another expression of the same quiet balance we have encountered throughout tonight's journey. Stars shape planets. Planets respond to stars. Neither remains unchanged forever. And somewhere beyond these slowly fading giants, astronomers found another remarkable world. At first glance, it appears almost comforting. Its deep blue color reminds many people of Earth's oceans viewed from space. But appearances can be wonderfully misleading, for beneath those beautiful blue clouds lies a place where powerful winds race endlessly through the atmosphere, and where rain itself is made not of water, but of tiny fragments of glass, carried sideways across an alien sky. As you continue drifting through the quiet architecture of distant planetary systems, you may begin to notice that the universe has a fondness for gentle illusions. From far away, many worlds appear peaceful. A small point of light, a soft color, a calm orbit around a distant star. Only when astronomers patiently gather more observations do those quiet points begin to reveal their hidden stories. One of the most beautiful examples is a planet known as HD 189733b. Its scientific name is long, but there is no need to remember it. Tonight, you may simply think of it as the blue world. When astronomers first studied this distant giant, they noticed something remarkably familiar. Its atmosphere reflected a deep blue color. For a brief moment, it was difficult not to think of Earth. After all, when astronauts look back toward our own planet from space, they often describe seeing a brilliant blue world wrapped in soft white clouds. Blue has become, in many ways, the color of home. It reminds us of oceans stretching toward the horizon, clear summer skies, quiet lakes reflecting the evening light. It feels peaceful, comforting, gentle. Yet the blue world waiting around this distant star tells a very different story. Its color is not created by wide oceans or familiar skies. Instead, the atmosphere scatters certain colors of starlight, while containing tiny particles unlike anything drifting through the air above Earth. From a great distance, the result is beautiful. Up close, it would be almost unimaginably hostile. This remarkable planet belongs to the family of hot Jupiters we visited a little earlier. Like WASP-12b, it circles astonishingly close to its parent star. The warmth it receives is continuous and intense. Its atmosphere is heated until ordinary ideas about weather begin to lose their familiar meaning. If you could somehow stand within those clouds, you would discover that words like breeze or storm are no longer quite large enough. Powerful winds race through the atmosphere at astonishing speeds. They never seem to tire, they never truly stop. Instead, they circle the planet almost endlessly, carrying tremendous amounts of heat from the side facing the star toward the darker hemisphere beyond. Imagine standing beside the ocean during a strong winter storm. The wind presses steadily against your coat. You hear waves crashing again and again along the shore. Now imagine multiplying that force many times over. The air itself becomes a great flowing river surrounding the planet. Not a river of water, a river of atmosphere, constantly moving, constantly reshaping the clouds. Yet perhaps the most remarkable feature of this distant weather is something that sounds almost like poetry. Astronomers believe that high within parts of the atmosphere, tiny particles made from silicate materials may condense into clouds. Silicates are among the same broad family of minerals that help form rocks and sand here on Earth. Under the extraordinary conditions found on this planet, those materials behave in unfamiliar ways. As temperatures and pressures change, tiny droplets may form before eventually falling downward. People often describe this process as glass rain. It is a beautiful phrase, but it can also be slightly misleading. It is easy to imagine sharp pieces of broken window glass falling from the sky. Nature is usually more subtle than that. Instead, scientists are describing tiny mineral particles that condense under tremendous heat before moving through the atmosphere. The exact details remain an active area of research. The important idea is not that ordinary glass windows somehow melt into clouds. Rather, the same basic ingredients that help create rock and glass on Earth behave very differently beneath conditions unlike anything our planet experiences. Even more fascinating is the direction in which this remarkable rain may travel. Because the winds are so powerful, many researchers believe that these tiny mineral droplets could be carried sideways across the atmosphere, rather than simply falling straight downward. Imagine watching snow during a powerful winter gale. Instead of drifting gently toward the ground, the flakes race almost horizontally through the air. Now replace snow with glowing mineral particles moving through a sky heated far beyond any earthly desert. The picture becomes wonderfully unfamiliar. This planet also appears to keep one face turned toward its star, much like several other worlds we have already visited tonight. One hemisphere lives beneath endless daylight. The other remains beneath an endless night. Between them lies a broad region where light and darkness slowly meet. Not at sunrise, not at sunset. Simply in a quiet boundary that barely changes over countless generations. The atmosphere never stops trying to balance these extremes. Warm gases flow away from the bright side. Cooler gases return. The winds continue. The clouds continue. The weather becomes less like an event and more like a permanent conversation. As astronomers observe worlds like this one, they are reminded again that the universe often enjoys disguises. A blue planet need not contain oceans. A bright world may be freezing. A dark planet may be intensely hot. Color alone rarely tells the whole story. This is one reason astronomers are so careful when studying distant planets. A single observation can be beautiful. Many observations together begin revealing the truth. Each telescope adds another small piece to a much larger puzzle. Over time, the picture quietly grows clearer. There is something comforting about this gradual process. No single discovery needs to explain everything. Knowledge arrives gently. Observation after observation, question after question. Just as a landscape slowly emerges when morning mist begins lifting from a quiet valley. The valley was always there. You simply needed enough light to see it. Perhaps the universe itself is much the same. It has never hidden its wonders from us. They have simply been waiting patiently until our understanding became ready to notice them. The blue world reminds us that beauty and gentleness are not always the same. Some of the loveliest places in the universe would be impossible places for life as we know it, yet they remain deeply beautiful in their own quiet way. And as our journey continues, we will gently leave these extraordinary planets behind and turn our attention toward the stars themselves. For every remarkable world we have visited tonight was shaped by a far older companion. Some stars live calm, patient lives for billions of years. Others burn with astonishing intensity, spending their energy quickly before racing toward extraordinary endings. The next chapter of our journey begins with those brilliant giants, whose lives are far shorter than you might expect, yet whose influence stretches across the galaxy long after their light has faded. As your journey slowly leaves behind the remarkable worlds that circle distant stars, your attention naturally begins to rise toward the stars themselves. After all, every planet has a beginning. Long before mountains formed, long before oceans gathered, long before frozen comets drifted through the darkness, there was a star. It is easy to think of stars as permanent. When you step outside on a clear evening, many of the familiar patterns in the sky seem almost unchanged from one year to the next. The same constellations quietly return. The same bright lights greet countless generations. They seem timeless. Yet every star is living through a story. Some simply tell that story much more slowly than we do. A star begins its life inside a great cloud of gas and dust, drifting through space. At first, the cloud appears calm. Nothing seems hurried. Tiny particles float almost silently through the darkness. Yet gravity is already at work. Little by little, it encourages more material to gather together. The growing cloud becomes denser. Its center slowly grows warmer. Over countless thousands of years, the gentle pull of gravity continues its quiet work until something extraordinary happens. Deep within the center, pressure becomes so great that the smallest building blocks of matter begin joining together. In that quiet moment, a star is born. Light begins its long journey outward. Warmth spreads through the surrounding darkness. A new chapter quietly begins. From that point onward, one simple characteristic shapes almost everything that follows: its mass. You can think of mass as the amount of material the young star gathers during its earliest years. Some stars collect only a modest amount, others gather astonishingly more. That single difference quietly determines how the rest of their lives unfold. Imagine two campfires built on a peaceful evening. The first is small. Only a few carefully arranged pieces of wood burn together. The fire is gentle. It gives off enough warmth for a long conversation beneath the stars. The second fire is enormous. It blazes brightly. Its flames leap high into the night. Everyone notices it immediately. But because it burns with such intensity, its fuel disappears much more quickly. Stars behave in much the same way. A small star burns its fuel slowly, patiently, almost carefully. A very large star shines with extraordinary brilliance, yet that tremendous brightness comes with a quiet cost. It uses its fuel much faster. This surprises many people. We often assume that larger things should naturally last longer. In everyday life, that seems reasonable. A larger candle usually burns longer than a smaller one. A larger water tank usually empties more slowly. But stars follow a different rhythm. The brightest stars are often the least patient. They live intensely. They shine magnificently. Then, far sooner than their smaller neighbors, they reach the final chapters of their lives. Our own sun belongs comfortably between these extremes. It is neither unusually small nor exceptionally large. Its steady pace has allowed life on Earth to develop over billions of years beneath relatively stable conditions. If our sun were one of the largest stars in the galaxy, Earth would almost certainly never have enjoyed such a long period of quiet consistency. Sometimes, ordinary is exactly what makes life possible. As smaller stars continue aging, they gradually begin changing. The supply of fuel at their centers slowly decreases. Gravity gently gains the upper hand. The central region contracts. At the same time, the outer layers slowly expand. The star grows larger, cooler at its surface, redder in appearance. Astronomers call this stage a red giant. The name sounds dramatic. The transformation itself is wonderfully patient. Imagine watching a great old tree through many autumns. Each year it grows a little broader. Its branches stretch a little farther. Nothing changes overnight. Yet after many seasons, you suddenly notice how much it has grown. Stars experience a similar kind of quiet aging. For truly massive stars, however, the story becomes even more remarkable. Instead of becoming ordinary red giants, they grow into red supergiants. The word supergiant is simply our way of acknowledging how enormous these stars become. Some grow so large that, if one were placed where our sun now shines, its outer atmosphere would extend far beyond the orbit of Earth. It is difficult to imagine such immense size, yet despite becoming so vast, these stars are already approaching the ends of their lives. Inside their glowing hearts, new kinds of fuel begin replacing the old. Each stage lasts a little less time than the one before. The star works harder, it shines more brilliantly. Its great journey quietly accelerates. Imagine a traveler climbing a long mountain path. At first, the pace is relaxed. Each step feels easy. Later, as the summit draws nearer, the climb becomes steeper. The traveler breathes more deeply. The effort increases. The destination approaches more quickly than expected. Massive stars seem to follow a similar rhythm. The closer they move toward their final chapter, the faster that chapter unfolds. Yet there is nothing tragic about this process. Without these giant stars, the universe would be a much quieter place. Deep within their blazing interiors, many of the heavier elements needed for rocky planets and living creatures are gradually created. The calcium in your bones, the iron carried quietly through your blood, the oxygen you breathe. Long before they became part of Earth, many of these elements were patiently forged inside stars that lived and died billions of years ago. In a very real sense, every peaceful evening beneath the stars is also a quiet reunion with ancient starlight. There is something deeply comforting in that thought. The universe is wonderfully good at recycling. One generation of stars gently prepares the materials for the next. Those younger stars eventually build new planetary systems. Some planets become homes for oceans. Some become deserts. Some remain frozen. Some glow with molten rock. Each begins with the quiet gifts left behind by much older suns. Among the oldest and hottest of these remarkable stellar lives are a rare family of stars unlike almost any others. Their outer layers have already been stripped away. Their brilliant hearts shine almost directly into space. They burn with astonishing intensity, glowing with a blue-white light that seems almost beyond imagination. One of them, quietly waiting ahead on our journey, is known as WR102. Its story begins where many other stars are already coming to an end. As you continue drifting through the quiet lives of the stars, you may begin to notice something almost comforting. Nothing in the universe seems eager to hold on forever. Stars do not cling to their youth. Planets do not resist the slow passage of time. Even galaxies gently change their shapes over unimaginable ages. Everything seems willing to become something new. Perhaps that is why the oldest stars often appear among the most beautiful. Earlier, you quietly watched how a star's life depends upon the amount of material it gathers when it is born. Some stars choose the slow path. They burn steadily for billions of years, almost as though they are carefully protecting every small piece of fuel. Others begin their lives with extraordinary abundance. They shine brilliantly. They illuminate vast regions of space. Yet they spend their energy with remarkable generosity. Their brightest years pass surprisingly quickly. As these massive stars approach the final chapters of their lives, something remarkable begins to happen. Instead of quietly holding their outer layers close, they slowly release them. Not all at once, not in a dramatic explosion. Rather, the star begins breathing itself into the surrounding darkness. Powerful streams of particles flow steadily outward, hour after hour, century after century, million after million of years. Astronomers often describe these steady outflows as stellar winds. The words may suggest something similar to the breeze you might feel across your face on a peaceful evening. The reality is much more powerful, yet the idea remains surprisingly gentle. Imagine standing beneath a great old tree during autumn. One leaf loosens, then another. A soft breeze carries them away. The tree is not being destroyed. It is simply changing, preparing for another season. A massive star experiences something wonderfully similar, although on a scale almost beyond imagination. Instead of leaves drifting away, entire layers of hot gas slowly stream outward into space. Those glowing gases continue expanding long after they have left the star itself. Gradually, the brilliant outer atmosphere becomes thinner. Little by little, deeper layers begin to appear. It is almost as though the star is quietly removing one warm blanket after another, revealing an even brighter heart beneath. Astronomers call these remarkable objects Wolf-Rayet stars. The name comes from two 19th-century astronomers who carefully studied their unusual light. Tonight, however, you do not need to remember those names. It is enough simply to imagine a star that has gently uncovered its own glowing heart. Among this rare family is a remarkable example known as WR102. Even among Wolf-Rayet stars, it quietly stands apart. It is considered one of the hottest stars ever carefully studied. Its surface glows with an extraordinary blue-white light, so energetic that it becomes difficult for human imagination to fully picture. Rather than trying to imagine impossible temperatures, perhaps it is easier to think about what that light represents. This is a star approaching the final pages of a very long story. Everything it has quietly built throughout its lifetime is now being revealed. The powerful winds continue carrying material outward into space. Those expanding gases create magnificent glowing clouds around the star. To a distant observer, the scene might almost resemble a lantern shining through thin morning mist. The lantern itself remains bright. Around it, delicate layers slowly drift farther into the darkness. Nothing appears hurried. Even here, among some of the most energetic stars in the galaxy, nature continues working with extraordinary patience. The winds blowing away from WR102 travel at astonishing speeds. Yet because space itself is so unimaginably vast, even those tremendous outflows spend years crossing regions that appear almost empty. The universe has a remarkable way of making even the fastest journeys feel quiet. As the star continues losing material, another invisible process quietly unfolds deep within its center. Heavier and heavier elements are created one after another. Each stage lasts a little less time than the previous one. The star shines brilliantly while steadily preparing for its final transformation. Eventually, stars like WR102 are expected to end their lives in tremendous stellar explosions, known as supernovae. The word itself sounds dramatic. Tonight, there is no need to imagine violence. Instead, imagine a great bonfire that has warmed countless travelers through a long night. As dawn slowly approaches, the fire finally gives away the last of its glowing embers. Those embers drift outward into the cool morning air. They settle across the surrounding ground. Months later, tiny green shoots quietly appear where the ashes once rested. The fire has ended, yet something new has already begun. Stars follow a similar rhythm. When massive stars finally reach the end of their lives, they scatter many of the elements they have patiently created across the surrounding galaxy. Those elements become part of new clouds, new stars, new planets, perhaps even future oceans and forests. Without stars like WR102, many of the materials needed for rocky worlds would never become available to future generations of planetary systems. The universe does not waste very much. Again and again, it quietly reshapes yesterday into tomorrow. There is something deeply reassuring about that endless cycle. Nothing simply disappears. Everything changes form. The light leaving WR102 tonight will continue traveling long after the star itself has completed its remarkable journey. Some of those ancient photons may one day pass through another young planetary system. Some may quietly cross the empty spaces between galaxies. Some may simply continue wandering through the darkness for billions of years, carrying with them the silent memory of a star that once burned with extraordinary brilliance. As you gently leave WR102 behind, you may notice that your perspective has quietly changed. For much of tonight's journey, you have explored individual worlds, individual stars, individual travelers between distant suns. Now the view begins to widen. Far beyond any single star lies something even grander. Stars are rarely alone. Like trees gathering to form forests, billions of them quietly come together, creating vast islands of light that drift through the universe together. Our next gentle step will leave the lives of individual stars behind and begin exploring those immense stellar families we simply call galaxies. As you quietly leave behind the brilliant life of WR102, something begins to change. Until now, your attention has rested upon individual stars. Each one carried its own story, its own beginning, its own slow transformation, its own quiet ending. But the universe has another gentle surprise waiting. Stars rarely spend their lives alone. If you could somehow drift far above our galaxy and look back across the darkness, you would not see isolated stars scattered randomly through space. Instead, you would discover enormous gatherings of light, billions upon billions of stars, quietly traveling together through the universe. These immense families are called galaxies. The word itself may sound grand, yet the idea is wonderfully simple. Imagine standing at the edge of a peaceful forest. One tree is beautiful. You can admire its branches, its leaves, the way sunlight rests upon its bark. But when you slowly step backward, another tree comes into view, then another. Soon you realize that what first appeared to be a single tree is actually part of something much larger, a living forest. Stars are much the same. Each one shines with its own quiet light. Together, they create something even more remarkable, a galaxy. Gravity, once again, is the quiet artist behind the scene. Long before galaxies became the graceful structures we observe today, the young universe contained immense clouds of gas spread gently through space. The matter was not perfectly smooth. Some regions held just a little more material than others. The differences were almost unimaginably small. Yet gravity is wonderfully patient. Where slightly more matter gathered, gravity became just a little stronger. That stronger pull attracted even more material. Very slowly, tiny differences became larger ones. clouds became larger clouds. Those clouds slowly fragmented into countless new stars. Over immense stretches of time, entire galaxies quietly emerged. It is rather like watching tiny streams flowing across a hillside after gentle rain. Each stream begins almost unnoticed. As more water joins, the streams become rivers. The rivers continue gathering together until they finally reach the sea. Nothing hurries. The landscape simply follows gravity's quiet invitation. Galaxies seem to grow in much the same way. Some become graceful spirals. Others become soft glowing spheres. Still others take on irregular shapes that seem almost playful. Astronomers usually describe galaxies using three broad families. The first are spiral galaxies. These are perhaps the easiest to recognize. Imagine watching cream slowly stirred into a cup of coffee. Gentle curves begin appearing. Soft arms slowly wrap around the center. Many spiral galaxies display similar sweeping patterns, although their shapes are created not by stirring, but by billions of stars quietly moving together under gravity's guidance. Our own Milky Way belongs to this family. From within, however, it is surprisingly difficult to appreciate its full shape. It is rather like trying to understand the outline of an entire forest while standing among its trees. You see countless individual trunks. You notice sunlight filtering through the branches, yet the forest itself remains difficult to picture until you rise high above it. Because we live inside the Milky Way, astronomers have spent many decades patiently building a larger picture from countless careful observations. Little by little, our galactic home has revealed itself. The second family consists of elliptical galaxies. Unlike graceful spirals, these galaxies appear smoother and rounder. Their stars travel along many different paths, creating broad, glowing shapes without clearly defined arms. If spiral galaxies resemble gently turning whirlpools, elliptical galaxies may feel more like softly glowing lanterns, floating quietly through the night. They often contain many older stars, whose brilliant youth has long since passed into calmer chapters of existence. There is something wonderfully peaceful about them. The third family includes irregular galaxies. These refuse to fit comfortably into simple descriptions. Some have been stretched by close encounters with neighboring galaxies. Others continue forming stars so actively that their shapes remain wonderfully uneven. Rather than seeing disorder, perhaps it is better to think of them as galaxies still quietly writing their own stories. Nature rarely insists that everything become perfectly symmetrical. Sometimes the most beautiful landscapes are the least predictable. As telescopes grew more powerful, astronomers discovered that galaxies themselves often gather into larger communities. Just as stars form galaxies, galaxies gently keep one another company across enormous distances. Even our own Milky Way is not alone. Several smaller companion galaxies quietly travel nearby, each following its own patient path around our galactic home. Some are so faint that they remained unknown until surprisingly recent years. Others have been visible for centuries beneath dark southern skies, appearing as soft, glowing patches to careful observers. These smaller companions remind us that galaxies also exist within families. Nothing in the universe seems entirely isolated. There is always another layer waiting beyond the one we have just begun to understand. Perhaps that is one of the quiet themes woven throughout tonight's journey. Planets belong to stars. Stars belong to galaxies. Galaxies belong to larger neighborhoods still. Every step backward reveals a broader view, yet nothing loses its own quiet importance. Earth remains beautiful, even though it is only one world. The sun remains extraordinary, even though billions of other stars shine beside it. The Milky Way remains magnificent, even though countless galaxies quietly drift beyond it. Perspective does not diminish beauty, it deepens it. And among all the companions traveling beside our own galaxy, one has quietly shared our cosmic neighborhood for billions of years. From the southern hemisphere of Earth, It appears as a faint cloud suspended beneath the stars, gentle, unhurried, almost easy to overlook. Yet within that soft glow are billions of stars, remarkable stellar nurseries, and some of the most extraordinary suns ever discovered. Our next quiet destination is that neighboring island of light, known as the Large Magellanic Cloud. As your view slowly widens beyond the familiar stars of the Milky Way, another gentle light begins to appear. It is not bright enough to command attention. It does not stretch boldly across the sky. Instead, it waits patiently, a soft mist of light, quietly hanging beneath the stars of Earth's southern hemisphere. For countless generations, people noticed this gentle glow without fully understanding what it was. To the naked eye, it resembles a small cloud that never drifts with the wind. It remains in the same place, season after season, quietly reminding patient observers that not every cloud belongs to Earth's atmosphere. Long before telescopes became powerful enough to reveal its true nature, this quiet patch of light had already been traveling beside our galaxy for billions of years. Today, we know it as the Large Magellanic Cloud. Despite its peaceful appearance, it is not a cloud at all. It is another galaxy, a smaller companion that has shared the Milky Way's neighborhood for an unimaginably long time. If the Milky Way is like a great ancient forest, then the Large Magellanic Cloud is a nearby woodland growing quietly along its edge. Smaller, younger in many places, yet filled with its own remarkable life. It contains billions of stars. Some are ancient, having shone for vast stretches of cosmic history. Others are astonishingly young, only recently born from great clouds of gas that continue drifting through the galaxy. Unlike many older galaxies where star formation has slowed, the Large Magellanic Cloud remains wonderfully active. Even now, new stars continue appearing within its glowing clouds. It is almost like walking through a forest where old, towering trees stand beside tiny green saplings that have only just emerged after gentle spring rain. The generations quietly overlap, nothing rushes. Everything simply continues. One of the most extraordinary places within this neighboring galaxy is a vast region where stars are still being born. Astronomers call it the Tarantula Nebula. The name may sound dramatic, but tonight there is no need to imagine anything frightening. Instead, picture a great valley filled with softly glowing mist. Within that mist, gravity patiently gathers gas together, allowing countless young stars to begin their long journeys. If you could safely drift through this remarkable region, you would not hear explosions or rushing winds. Space itself is almost completely silent. You would simply see immense glowing clouds, illuminated by newborn stars whose brilliant light slowly spreads through the surrounding gas. Some of those young stars belong to a remarkable gathering known as R136. Rather than being a single star, R136 is a densely packed cluster containing many of the youngest and most massive stars astronomers have ever studied. Imagine walking into a quiet village where nearly every house has just welcomed a newborn child. Energy fills every corner. Everything feels new. Everything is only beginning. That is something like the atmosphere within this extraordinary stellar nursery. Many of its stars are so massive that they will spend their fuel quickly, living lives far shorter than smaller stars like our own Sun. Once again, the universe gently reminds us of a lesson we encountered earlier. The brightest flames often burn for the shortest time. Yet even as some stars begin their brilliant lives, others within the same galaxy are quietly approaching their endings. Among them is an extraordinary giant known as WOH G64. Where R136 speaks of youth, WOH G64 whispers of age. It is a red supergiant, a star that has expanded enormously after spending millions of years quietly transforming the fuel within its heart. Its outer atmosphere stretches far into surrounding space, wrapped in enormous clouds of dust that gently soften its light. If R136 resembles the laughter of childhood, then WOHG64 feels more like the quiet wisdom of old age. The two exist within the same galaxy, the beginning and the ending of stellar life quietly sharing the same neighborhood. There is something deeply comforting about that balance. Every beginning already carries the promise of change. Every ending quietly prepares the way for something new. The large Magellanic Cloud itself also continues changing. Gravity gently binds it to the Milky Way. The two galaxies are not standing still. They move together through space, slowly influencing one another across enormous distances. The pull between them is gentle. There is no sudden collision, no dramatic rush. Instead, gravity patiently shapes both galaxies over hundreds of millions of years. Imagine two dancers moving slowly across a quiet ballroom. Neither forces the other. Each subtly responds to the other's motion. Together, they create a graceful dance that no single step can fully explain. Galaxies often behave in much the same way. Their dance unfolds so slowly that no human lifetime could ever witness a noticeable change. Yet, the dance continues nonetheless. Astronomers have also discovered that much of the large Magellanic Cloud's true mass is invisible. Like our own galaxy, it appears to be surrounded by an enormous halo of unseen matter, whose gravity quietly helps hold everything together. We cannot observe this mysterious material directly. Instead, we notice its gentle influence through the motions of stars and gas. It is another reminder that the universe often reveals itself indirectly. Sometimes the most important things are known not because we see them, but because we quietly notice the way they guide everything around them. The more we study our neighboring galaxies, the more familiar they begin to feel. Although each possesses its own character, they all seem to follow the same patient rhythms. Stars are born, stars grow older, stars return their materials to space. New generations quietly begin again. The universe rarely invents entirely new stories. Instead, it tells the same beautiful story in countless different places. And beyond this quiet companion lies another neighbor, far larger and even more familiar to astronomers. On clear autumn nights in the northern hemisphere, it appears as nothing more than a faint oval of light. Many people have looked directly at it, without realizing they were seeing an entire galaxy with their own eyes. Its gentle glow began its journey toward Earth long before human civilization first learned to write. It has been traveling patiently through the darkness ever since. Our next destination is that ancient island of starlight, the Andromeda Galaxy. As your journey continues beyond the gentle glow of the large Magellanic Cloud, another island of light slowly begins to emerge from the darkness. It is larger, brighter, yet somehow even softer. On a clear autumn evening, far from the bright lights of cities, many people have looked directly toward it without realizing what they were seeing. To the eye, it appears almost like a delicate patch of mist. Not a star, not a cloud drifting through Earth's atmosphere. Simply a quiet blur suspended among countless points of light. It is easy to overlook. Yet hidden within that faint glow is an entire galaxy. A great gathering of stars, quietly accompanying the Milky Way through the vastness of space. This is the Andromeda Galaxy. There is something wonderfully humbling about seeing Andromeda with your own eyes. Unlike many distant galaxies that require powerful telescopes, this one has always been waiting patiently above us. Long before astronomy became a science, people across different cultures noticed its soft glow. They could not know exactly what it was. Some imagined a cloud, some imagined a distant heavenly mist. The truth turned out to be even more beautiful. It was another galaxy entirely, a neighboring home for hundreds of billions of stars. Yet perhaps the most remarkable part of Andromeda is not where it is when it is. Whenever you look toward a distant object in space, you are also looking backward through time. Light does not arrive instantly. Even the sunlight warming Earth this morning began its journey several minutes before it reached your face. Moonlight has traveled a little longer. The light from distant stars travels longer still, and the gentle glow, arriving from Andromeda, has been crossing the darkness for millions of years. Imagine writing a letter to a dear friend. You place it carefully into an envelope. It begins a long journey across mountains, rivers, forests, and quiet villages before finally arriving. When your friend opens the letter, they are reading words you wrote long ago. The light from Andromeda is something like that letter. It carries an ancient message. Every tiny beam reaching Earth tonight left its galaxy long before human civilization looked anything like it does today. While that light quietly traveled through intergalactic space, continents continued drifting across Earth. Mountains slowly changed shape. Countless generations of living creatures appeared and disappeared. Human history unfolded beneath the stars. The light never hurried. It simply continued its quiet journey. There is something deeply peaceful about that thought. The universe is constantly sending messages. It simply speaks at the speed that light is able to travel. When astronomers study Andromeda, they are not only learning about a neighboring galaxy, they are also studying a beautiful memory preserved in light. As telescopes became more powerful, Andromeda gradually revealed itself in greater detail. Graceful spiral arms gently wrap around its bright central region. Dark lanes of dust weave quietly between enormous collections of stars. Glowing clouds mark places where young stars continue being born. From afar, the entire galaxy resembles a vast pinwheel, turning almost imperceptibly through the darkness. Yet even this graceful appearance tells only part of the story. Galaxies are never truly still. Every star within Andromeda follows its own patient orbit around the galactic center. Clouds of gas slowly move. New stars quietly appear. Older stars continue their long journeys toward gentler endings. The galaxy changes constantly. Only the timescale is so immense that the changes feel invisible to us. Imagine watching the hands of an old clock. If you stare for only a few seconds, they appear perfectly still. Leave the room. Return an hour later. The quiet movement becomes obvious. Galaxies invite the same kind of patience. Their clocks simply measure millions of years instead of minutes. Perhaps the most famous question surrounding Andromeda concerns its future relationship with our own Milky Way. Astronomers have carefully measured the gentle motion of this neighboring galaxy. Little by little, it is drawing closer. Not quickly, not dramatically, simply following gravity's quiet invitation. Many millions of years from now, the Milky Way and Andromeda are expected to meet. The word collision is often used to describe this distant event. It can sound rather alarming. It brings to mind crashing objects and sudden destruction. But galaxies are astonishingly spacious places. The distance separating individual stars is so enormous that, even as the two galaxies slowly pass through one another, direct collisions between stars are expected to be extraordinarily rare. Imagine two great clouds of tiny glowing fireflies drifting gently through each other on a warm summer evening. The clouds overlap, their shapes change, yet almost every individual firefly quietly continues its own path. Something similar is expected when our two galaxies eventually begin their slow dance together. Gravity will gently reshape both galaxies. Some stars will move into new orbits. New clouds of gas may gather. Fresh generations of stars may quietly begin. The meeting is less like two solid objects crashing together. It is more like two rivers slowly joining into one broader current. No rushing, no violence, only transformation unfolding with unimaginable patience. By the time this distant future arrives, our own sun will already be approaching the later chapters of its life. Earth itself may be very different, or perhaps no longer resemble the peaceful world we know today. Yet the galaxies will continue their gentle dance regardless. There is something strangely comforting in that thought. The universe carries on without urgency. Its greatest changes unfold so slowly that they almost become another form of stillness. As your imagination gently drifts across the ancient light of Andromeda, your perspective widens once more. The Milky Way is no longer simply our home. Andromeda is no longer simply our nearest great neighbor. Together, they belong to a larger family of galaxies, quietly traveling through the universe together. Beyond these two graceful spirals lie smaller companions, hidden members of the same cosmic neighborhood, each following gravity's patient guidance. Our next step will gently carry us beyond Andromeda itself, revealing the quiet community of galaxies that we have belonged to all along. As the ancient light of Andromeda gently fades behind you, something remarkable begins to happen. For much of tonight's journey, you have been moving farther and farther outward. First, you wandered among distant worlds. Then you drifted beside remarkable stars. After that, entire galaxies quietly unfolded before your eyes. Now, once again, your perspective gently widens. You begin to notice that even galaxies rarely travel alone. Just as stars gather into galaxies, galaxies themselves gather into quiet communities. The Milky Way is not an isolated island surrounded by endless emptiness. Instead, it belongs to a peaceful neighborhood. Astronomers call this neighborhood the local group. The name sounds wonderfully modest. It does not promise anything dramatic. It simply reminds us that, in the vast universe, even enormous galaxies have nearby companions. Imagine standing in a quiet countryside just after sunset. A few warm lights glow from nearby homes. Beyond them, more villages rest beneath distant hills. None of the houses stand completely alone. Each belongs to a wider landscape. The local group is something like that. Our Milky Way is one home. Andromeda is another. Around them are many smaller galaxies, each quietly following its own ancient path through space. Together, they form a family held gently together by gravity. Among these neighboring galaxies is another graceful spiral, known as the Triangulum Galaxy. It is much smaller than either the Milky Way or Andromeda, yet it possesses a quiet beauty entirely its own. If Andromeda resembles a great city filled with countless lights, Triangulum feels more like a peaceful town resting nearby. It shines softly, unhurried, comfortable in its place among larger neighbors. Within its spiral arms, stars continue being born. Clouds of gas slowly gather. Ancient stars quietly grow older. Its story is different from ours, yet guided by the same patient laws. Gravity does not play favorites. It simply continues its quiet work wherever matter chooses to gather. Surrounding these three larger galaxies are many smaller companions. Some are delicate collections of only a few million stars. Others appear stretched and softened after billions of years under the gentle influence of their larger neighbors. Rather than imagining these smaller galaxies as weak, perhaps it is kinder to think of them as quiet villages surrounding larger cities. Each possesses its own history, its own stars, its own gentle rhythm. The universe seems remarkably fond of companionship. Again and again, it gathers smaller things into larger families, planets around stars, stars within galaxies, galaxies within groups. Every step backward reveals another circle, quietly embracing the one before it. As astronomers continued mapping the nearby universe, they realized that the local group itself is only one small part of something even larger. Our neighboring galaxies all drift within a broad, gently flattened region known as the local sheet. The name may sound unusual, but the image is surprisingly simple. Imagine a wide meadow stretching peacefully beneath the morning sky. Villages are scattered gently across its fields. Each village belongs to the same landscape, even though the people living there may never meet. The local sheet is rather like that quiet meadow. Across immense distances, groups of galaxies share the same broad region of space, slowly moving together through the universe. No sharp boundaries separate one region from another. Everything blends gently into everything else. The farther your imagination travels, the softer those boundaries become. Beyond the local sheet lies an even greater gathering. Astronomers know it as the Virgo cluster. This remarkable collection contains hundreds, even thousands of galaxies quietly bound together by gravity. If the local group resembles a peaceful village, then the Virgo cluster is more like a vast countryside filled with countless towns, forests, rivers, and open fields stretching beyond the horizon. No single galaxy defines it. Instead, every member quietly contributes to the larger whole. It is difficult for the human mind to picture so many galaxies gathered together. After all, every galaxy already contains billions of stars. Every star may host planets. Every planet carries its own quiet possibilities. Yet the universe gently invites us to keep widening our view, again and again, without ever asking us to hurry. There is something wonderfully calming about this endless expansion of perspective. At every scale, familiar patterns quietly return. Gravity gathers, time shapes, light travels. New stars are born, older stars quietly fade. The same gentle rhythms echo across distances so enormous that numbers begin losing their meaning. Perhaps this is why astronomers often speak less about individual objects and more about relationships. A galaxy is beautiful by itself, yet it becomes even more meaningful when you understand where it belongs. The Milky Way belongs to the local group. The local group belongs to a larger neighborhood. That neighborhood belongs to something larger still. The universe seems less like a collection of isolated islands and more like an endless landscape where every part quietly influences another. In recent decades, astronomers have continued expanding this remarkable map. They have discovered that enormous gatherings of galaxies are linked together by vast streams and bridges of matter, forming an intricate pattern that stretches across unimaginable distances. From very far away, the universe begins to resemble delicate threads woven together into an immense tapestry. Not a perfectly regular pattern, not a rigid design, something softer, almost organic, like frost spreading across a winter window, or the branching veins within a quiet leaf, or gentle ripples expanding across a still lake after a single drop of rain. Tonight, however, there is no need to travel farther. Simply knowing that such larger patterns exist is enough. Sometimes wonder is gentlest when it remains slightly beyond reach. You have already traveled astonishingly far, far beyond the planets, far beyond the stars, far beyond the galaxies that first felt unimaginably distant. Now, standing quietly within this wider cosmic neighborhood, you may notice an unexpected feeling. The universe no longer seems quite so empty. Instead, it feels quietly connected. Every world belongs somewhere. Every star belongs somewhere. Every galaxy belongs somewhere, and so do you. In our final gentle step, we will not travel farther outward. Instead, we will slowly turn around. Together, we will look back across everything we have quietly explored tonight, allowing the immense universe to gently guide us home once more. Now, your journey gently begins to turn around. Not because there is nowhere else to go. The universe stretches far beyond everything we have quietly explored together tonight. Beyond the neighboring galaxies lie countless other gatherings. Beyond those gatherings are structures even larger, woven gently across the darkness like delicate threads of light. You could continue traveling outward for thousands of lifetimes and still never reach an edge. The universe does not seem eager to end. Instead, it quietly continues. But tonight, there is no need to travel farther. There is something equally beautiful about coming home. Imagine standing upon a quiet hill just before dawn. You have spent the night looking toward distant mountains, following rivers into unseen valleys, watching stars slowly cross the sky above you. Now, almost without noticing, your attention begins returning. The mountains remain. The rivers continue flowing. The stars still shine. But your eyes slowly find the familiar path beneath your feet once again. That is where our journey now begins. Far away, the great gatherings of galaxies continue their patient motion. The Virgo cluster quietly follows gravity's timeless guidance. The neighboring groups drift almost imperceptibly through space. No one is directing them. No great clock announces each movement. Gravity alone, working with extraordinary patience, gently shapes their paths. As your view slowly narrows, the local group comes quietly back into focus. Andromeda continues sending its ancient light across the darkness. The Triangulum galaxy patiently turns among its own stars. Smaller companion galaxies quietly accompany them, each following an orbit that has unfolded over billions of years. Together, they remain a family, not because they chose to be, simply because gravity gently gathered them long ago. Now, the Milky Way slowly grows larger once again. Its graceful spiral arms wrap quietly around a bright central heart. Within those sweeping arms, countless stars continue living stories, almost impossible for any one mind to fully imagine. Some stars are only beginning to shine. Others are growing older. Some are quietly creating the elements that will one day become new planets. Others have already shared those gifts with the galaxy long ago. The Milky Way does not stand still. It breathes in its own quiet way. Stars orbit, clouds gather. Light continues traveling. Everything changes, yet everything belongs. As you drift gently inward, one small spiral arm becomes easier to notice. Among its countless stars shines one that appears entirely ordinary, not unusually bright, not unusually large, not especially rare. A quiet yellow star, the Sun. Throughout tonight's journey, you have visited stars that burned more fiercely, stars that were far hotter, stars that lived shorter, brighter lives. Yet none of them feel quite as familiar. Sometimes ordinary things quietly become extraordinary, simply because they are home. Around the Sun, the planets continue their ancient dance. Mercury quietly circles close to the warmth. Venus remains hidden beneath its brilliant clouds. Earth continues its patient journey. Mars follows faithfully beyond. Farther outward, the giant planets quietly guard the colder reaches of the solar system. Beyond them, icy worlds continue their slow journeys through the darkness. Comets still wander. Frozen bodies still drift beyond Neptune. Everything we explored during the first chapters of tonight's journey remains exactly where it has always been. Nothing needed our attention in order to continue. The universe carries on beautifully, whether anyone is watching or not. That thought may seem surprisingly comforting. There is no pressure to remember every name. No need to hold every scientific detail in your thoughts. The planets will continue orbiting. The stars will continue shining. The galaxies will continue their patient dance. The universe asks nothing of you tonight except your quiet company. As your imagination returns to Earth, the scale changes once more. The blue planet slowly turns beneath gentle clouds. Oceans quietly reflect sunlight. Forests breathe. Mountains rest beneath passing seasons. Rivers continue finding their way toward the sea. Somewhere upon that small world is the place where you are resting now. Perhaps outside your window, evening has already settled. Perhaps distant sounds drift softly through the air. Perhaps everything around you has grown wonderfully still. Your own breathing has quietly accompanied this entire journey. While galaxies slowly turned, while ancient starlight crossed unimaginable distances, while frozen worlds circled distant suns, your breathing continued, gentle, steady, patient. In some ways, it follows the same quiet rhythm we have found everywhere tonight. Nothing forced, nothing hurried, only one calm moment gently becoming the next. Perhaps that is the deepest lesson the universe offers. Not that it is unimaginably large, not that it contains astonishing stars or remarkable planets, but that every scale of existence seems connected by the same quiet patience. A seed slowly becomes a tree, a cloud slowly becomes a star quietly creates the elements for future worlds. Galaxies gently gather beneath gravity, time patiently shapes them all. You are not separate from that story, you are part of it. The oxygen you breathe was once carried inside ancient stars. The calcium within your bones was quietly forged deep inside stellar hearts long before Earth existed. Even the tiny atoms resting peacefully within your hands tonight have traveled extraordinary journeys across the universe before becoming part of you. There is something wonderfully peaceful about belonging to such an ancient story. You do not stand outside the universe observing it from a distance. You have always been inside it, you always will be. Long after tonight's journey gently fades into sleep, the stars will continue their patient work. The Milky Way will continue turning. Andromeda will continue approaching. New stars will quietly be born inside distant clouds. Old stars will gently share their final gifts. Nothing needs to happen quickly. Nothing needs to happen tonight. The universe has all the time it could ever need. And perhaps, for this quiet moment, so do you. You are safe. There is nowhere you need to travel now. Nothing you need to solve. Nothing you need to remember. Just the slow comfort of knowing that, among countless stars and galaxies, you already belong exactly where you are. Let the universe continue its endless journey, and you, at last, can simply rest.